Hello, hello, hello. Hi, am I audible to you? Hello, hello. Am I audible to you? Hello. Okay, thank you. Now we will start. By the request of many students, uh, we are going to start chapter number 4 again here. Point of view. So I would like to focus on the chapter number 4 again. As we all of us know that this chapter number 4 is completely theoretical chapter, but the many times questions are asked from chapter number 4 about 10 to 15 marks, so weightage is 15 marks. So we'll start this chapter number 4. The title is automation. First of all, we should know what is automation. Automation, it is any work that you do with the less interference of human being, that is called as automation. I am repeating. So any work that you do with the less human interference, that can be called as automation. Some students have one concept in the mind that for automation we require a mechatronics. With the help of mechatronics we can do the better automation. Okay, uh, that can happen. With the help of mechatronics we can do the automation, but the concept of automation is not limited to only mechatronics. Anything that you automize, simply, that can be automation. There is one type of automation that is called as a mechanical automation. Even you design one machine or device that only works on mechanical inputs, that does not work with the help of PLC programs or mechatronics technology, but that is also called as automation. Just remember this thing, that is also called as automation. So there is no need of PLC or robotics for automation. Without that, automation can happen, and with the help of PLC and robotics or mechatronics, automation may happen. So this is the basic funda. Just remember one line: with the less human interference you have to complete the task, that can be called as automation. Now we'll move ahead. What is the advantage of automation that we will see? Very first thing is the use. It uses special devices nowadays in CAD CAM. While talking about the CAD CAM subject, we are going to focus on the automation based on which is based on the mechatronics and different types of motors used in CNC, DNC systems, or in NC system also. So CAD CAM subject specially involves the use of external devices. Also it involves the programming of PLC programming, implementation of mechatronics, implementation of different embedded devices in automation. So it uses special devices and which performs and controls manufacturing processes, that I told you now. So for example, stepper motors are used in machines. Servo motors are also used in controllers. So these motors are specifically performing the task which is feeded into a part programs. So automation in CAD CAM subject, that is depending on electronics devices. Decision making in manufacturing, that becomes easier because of the automation. Now we'll see the types of automation. These three types are automation, types of automation: hard automation, soft automation, and flexible automation. What is hard automation? Sequence of operation is fixed by equipment configuration. So for example, I will directly put an example. Um, Example of Coca-Cola bottles, example of Bisleri bottles, their industries, their packaging, their feeding the bottles. So this plant is fixed for, their setup is fixed for years and years. Setup of the plant is fixed for years and years, and same type of products are manufactured in that plant for years and years. That comes under the hard automation. For example, standardized products like engine block, gears, or spindle. So these products are manufactured for years and years. So that can be called as a hard automation. Then less flexibility in changing sequence. This is also one drawback that we can say about the hard automation, because once you fix the plant, there is no scope for a modification in the plant. In case you want to do any modification in such type of plant, that will be more costly, and that may not be beneficial to the organization or to that plant. So there is no flexibility, only one type of product that you can manufacture in hard automation type. Then high production rate, this is one advantage, high production rate. Obviously, because hard automation is specifically used for increasing production rate, it is specifically used for mass production. I am repeating the word mass production. More than 5,000 components you can manufacture in a day, that is the capacity of such plants, and there you can get the high production rate. So in one a day you can manufacture obviously more number of products. Why this happens? Because there is only one type of product, there is no change, just you have to feed the raw material and you will get the final product of same type. So therefore it increases the production rate. High initial cost of investment. Obviously this is observed, because when you are going to set up a plant, you need a huge machinery, costly machineries, and their setup cost, building cost, then the required floor space is also more, because you are going to do almost all process of manufacturing in one plant, and the manufacturing product is of same type. So there obviously there will be initial cost will be high. So this is about the hard automation. Now we will see the soft type of automation. It is also called as a programmable automation. First is the greater flexibility by use of computer. Then a machine can be easily reprogrammed to produce new shape of the component. Then sequence of operations can be changed easily and suitable for batch production. See about this soft automation, greater flexibility by use of computer. See, in the previous month we have learned chapter number 8, that is manual part programming, and we had learned the different types of part program. And in the part program, obviously computers were used in CNC system to write the part program, and there is a scope for changing that part program, there is scope for modification of that part program. Modification of that part program is easily possible, and that comes under the soft automation. So this is not even applicable for the CNC machines, but this is applicable for general production process. Their computers are used, there some automated devices are used to handle the production process. So for example, material handling devices are also used in soft automation. These are also, obviously these are also used in hard automation, but in soft automation material handling devices are also used. So and their function you can adjust by using computers or some programmed devices. Obviously sequence of operations can be changed easily because this automation is dependent on say computer, and their operations can be changed by reprogramming. Operations can be changed by reprogramming, so therefore you can change the sequence easily. So it does not happen like a hard automation. Even though in hard automation computers are used, but there is a no scope for changing the sequence of operation. But in soft automation, setup is made up in such a way that you can change the sequence of operations by changing the part program or by changing the some programs feeded in a computer. Then it is suitable for batch type of production, uh, because there is a scope for changing the setup, there is scope for changing the programs, so it is only suitable for the batch type of production. Then next type of the production, it is also called as a flexible, next type of automation is also called as a flexible automation. Why it is called as a flexible automation? The word itself indicate flexible. It means variety of products can be produced in flexible type of automation. Then the change of the part program with no loss of production time, that can happen in flexible type of production. Then higher flexibility you can achieve in flexible type of production. Then high investment cost in flexible type of production, and flexible manufacturing system is a good example of flexible automation. Again I am repeating this statement, flexible manufacturing system is good example of flexible automation. Please note this sentence, because FMS we are going to learn separately, and it is important point as far as examination is concerned. So we will learn this separately afterwards. The flexible manufacturing system, variety of products, what does it mean? Variety of product, it means that suppose you have manufactured a product like a solid shaft you have manufactured, then you want to manufacture a spur gear, so there is a variety, no? Obviously structure of solid shaft is different and structure of spur gear is different, so this kind of a variety you can manufacture in flexible automation system. So there is a scope for changing type of product, there is a scope for changing type of product in flexible automation. Afterwards we will see one more point that is called as a part family, that comes under group technology. So part family, that concept we will see again, but group technology is important to increase the production rate, to simplify the production process, and that all comes under the flexible type of automation. Obviously that depends on the machine cell, that machine cell concept also we will see again, but flexible manufacturing system is one type of machine cell. So machines are arranged in such a way that you can manufacture different types of product at a time, you can manufacture different types of product at a time. So that will not also create a loss of time, that will not create a loss of time also. Sometimes what happen when you change the type of products, as I told you, you want to manufacture the spur gear instead of a solid shaft. You want to manufacture spur gear instead of solid shaft, so type of product is changed now. But in the case of flexible automation, while changing this type of product, there will not be a loss of more time, so it will not hamper a production rate. Finally, it will not hamper a production rate. That is the good advantage of flexible automation. Now this graph you can see here, this explains the three types of automation in short. So here x axis represents the production volume. You can consider it as a quantity of production. X axis represents quantity of production, low quantity of products, medium quantity of products, and high quantity of products, that can be called as a production volume. And here product variety means different types of product. Less variety, only one or two products, different types of products you can manufacture. Medium type product variety, it means very less scope is also there. Medium scope is there to change the type of product, but high scope is there to change the type of product. So for example, you want to manufacture nut bolt, again you want to manufacture solid shaft, you want to manufacture knuckle joint, you want to manufacture spur gear. So high scope is there for manufacturing different types of product, that is what high product variety. And then medium product variety, and then low product variety. Now here you can see fixed automation, that is called as also called as hard automation, that we have learned just before 10 minutes. Hard automation, obviously high quantity of the products you can manufacture in hard automation. In medium type of automation or flexible type of automation, batch production is possible and product variety is less, that you can call it as medium also. But in programmable automation, there is a high product variety but low production rate. High product variety, low production rate or low production quantity, medium production quantity, and high production quantity. So again I am repeating this diagram. High production quantity in fixed type of automation, medium production quantity in flexible automation, and high low production quantity in programmable automation. Now in case of a fixed automation, low product variety, less product variety. In case of flexible automation, less or medium product variety. In case of programmable automation, high product variety. So if you want to increase the production rate, you have to compromise for product variety. If you want high product variety, you have to compromise for production volume or production quantity. So this will happen. Now next we will see, just wait, there is some problem I think. Advantages of automation: high production rate and increased productivity. This is one advantage of automation. Obviously production rates are going to increase, productivity will also increase. More efficient use of materials, that is less scrap. You have worked on the lathe machine in our workshop, and there are more scraps generated at the time of manufacturing processes, and later on these scraps are given to the industry and they can mold it again and they can manufacture new raw material. That process will happen. But what happens in automation, take an example, we will discuss an example of CNC machine. One product you have manufactured, and same type same product, same program you want to repeat 100 times, so that 100 products will manufactured. You have to check that component precisely, you have to check its quality precisely, and you will, if you grant that product, remaining 99 components will have the same accuracy, same quality. That is the greater advantage of the automation process. So in the CNC, DNC system or NC system, you can manufacture same product again and again with precise quality, quality, precise dimensions. So this is the advantage of automation. Then better product quality. Better product quality, obviously it will be there. See, first of all, I want to hear clear one concept of quality. So quality, it is not related to the accuracy, it is related to the fitness for purpose. I am repeating my statement, fitness for purpose, this is what a quality. So for example, one gear, it is precisely manufactured and that is used in gearbox of automobile, and one gear, it is manufactured by a casting process that may be used in conveyors in sugar industry. So you may present your opinion that, sir, the gear used in conveyors, it has low quality, and gear used in gearbox of automobile, it has good quality. So this is a wrong funda, or this is a wrong concept, because that gear used in conveyors, it is fit for that use, that application, and gear used in gearbox, it is fit for gearbox purpose in automobile. So both gear are satisfying their needs, both gears are satisfying their needs, and both are obviously having good quality. So quality is not dependent on the precise dimensions or the accuracy, it depends on the fitness for the purpose. Suppose you buy one chair and you are not feeling comfortable to sit in that chair for a lot of time, so you will say that quality is not good, so it is not fit for your purpose. So this is what the basic funda of the quality, please note down this. Then improved safety, obviously it is there in automation. Safety of the everything, safety of the machine, safety of the person, safety of the workpiece. Workpiece safety, it means that there is no chance for the scrapping that raw material, that is what safety of the workpiece also. So safety of every parameter is taken, regular maintenance is done to avoid the breakdown also. Then short work weeks for labor. I will rather it is called as, I will call it as a disadvantage. Short work weeks for labor means labor time is reduced. In turn, you can reduce the labor cost. It is advantage for industry because employment is reduced. Obviously, one machine is there and it works equivalent to 100 workers. That is the capacity of one machine. So short work weeks for labor. Previously, what previously it was happening that almost 100 days were taken to complete the work orders, but nowadays only 10 days are sufficient for manufacturing or completing the work orders. So this is happening because of what? Shorter work weeks. If you increase the work weeks, then labor time will increase and you have to pay more to the labor, and this is avoided because of the automation. Then reduced factory lead times. So obviously manufacturing time, time required for the manufacturing is also reduced, and thereby you have increased the production rate by using automation. Now you see the limitation of automation that I discussed just now. Worker unemployment, this is the limitation of automation. Then high capital expenditure required to invest in automation, this is also limitation. A higher level of maintenance needed than with a manually operated machine. Obviously, maintenance cost of such CNC, DNC, or any kind of automated device, that is more as compared to manually operated machines. Generally, lower degree of flexibility in terms of possible products as compared with a manual system. The lower degree of flexibility in terms of possible products as compared with manual system. So what does it mean? If you want to manufacture different type of products by using automation, so their configuration is fixed. Suppose you want to manufacture solid shaft, then you want to manufacture spur gear, then you want to go for nut and bolts or different types of coupling or joints. So this configuration is fixed in automation plant. But if you take an example of manual system, take an example of our college workshop. Variety of products you can manufacture, so you don't need to change the setup also. Just you have to go to the machine and manufacture any product or any workpiece or any desired product. So therefore degree of flexibility is more in manual system, but degree of flexibility is less in automation. This is the limitation to the automation. So it depends on the configuration of that plant. Now this bit is very important. Group technology. What is the group technology? This is important. I am requesting all of you to concentrate on this concept, because last time in the lecture also I had explained this 2 times. Some students may have confusion to understand. Please listen this carefully. Group technology is a manufacturing philosophy in which similar parts are identified and grouped together to take advantage of their similarities in manufacturing and design. I am repeating the statement slowly. Please listen. Group technology is a manufacturing philosophy in which similar parts are identified and grouped together to take advantage of their similarities in manufacturing and design. And similar parts are arranged, and that arrangement is called as a part family. One example we will take: a plant producing 10,000 different parts may be able to group the vast majority of these parts into 50 or 60 distinct families. Each family would possess similar design and manufacturing characteristics. Hence, the processing of each member of a given family would be similar, and this results in manufacturing efficiency. Now I will come to the explanation. Suppose there is a work order in your machine cell or in manufacturing industry. They want to manufacture solid shafts of diameter 30. Also there is a second order. They want to manufacture solid shaft of diameter 40. Also there is a third order. They want to manufacture solid shaft of diameter 10 mm. So what you think? You have to manufacture 3 different shafts, but their dimensions are also different. But why don't you focus on their manufacturing process? Even though their dimensions are different, their shape is same. Manufacturing operations required in the manufacturing of the solid shaft are same, so you can group them together. I am repeating, you can group all these order together and you can start manufacturing. So what is the advantage? Manufacturing operations are same, so this is the similarity of the product, because shape is same. So in this case you are saving the time of manufacturing, you are saving time required to set up the manufacturing devices. I am repeating, you are saving the time required to set up the manufacturing devices. This is the good advantage of the group technology. So you will group these all shafts of different dimensions, 10 mm dimensions, 30 mm dimension, and 40 mm, and this group is called as a part family. Now we will move ahead. What is the advantage of this philosophy? Obviously, group technology is used in many industries and it is done automatically. In case there is a huge plant and their mass production is more, in that case, group technology, this work is done by software itself. The name of the software is a SAP software. Reduced setup times, as I told you the same here. Setup time means what? The manufacturing facilities, arrangement of manufacturing facilities, time required to arrange the manufacturing facility, that can be called as a setup time in manufacturing process. Lower in process inventories. In process inventory means what? So for example, you need a coolant for manufacturing process, some material handling devices, some inspection devices, some gauging devices you need. In process means when manufacturing process is going on, you need this kind of process inventories which are required to continue the manufacturing process. These are also lowered. Then better scheduling, you can do the schedule, better schedule of the manufacturing process. See, for 1 hour you will take the shaft for manufacturing having 10 mm diameters. In the next second hour or in the next third hour you will take shaft for manufacturing having 40 mm diameter. In the next half hour you will take the shaft for manufacturing having 40 mm diameter. So scheduling you can do in better way. Then improved tool control. Obviously, improved tool control, what does it mean? One shaft you have manufactured, second shaft you have manufactured, third shaft you have manufactured, and third shafts you have manufactured, and their dimensions are different, but the tool you have used, it is same. It is not going to change. Obviously, it is not going to change. So tool setup is fixed. Setup of the tool is fixed and it will not change because same characteristics are there of manufacturing. So you don't need to change the tool. So that is what improved tool control. The use of standardized process. So standard process is used in group technology. All these processes are planned and according to the process you can go ahead with the manufacturing. The same thing I told you, I am reading once again now. A production equipment is arranged into machine groups or cell in order to facilitate workflow and part handling. See, as per the requirement of manufacturing process, production equipments are arranged. I am repeating, as per the requirement of manufacturing process, machines are grouped together. Machines are grouped together. So for example, you want to manufacture spur gear. So manufacturing of spur gear, it requires around 3 to 4 machines and these are grouped together. So from one machine raw material go to the second machine, second to third, third to fourth, and this cycle will continue. This cycle will continue in manufacturing process. Now this philosophy can be applied in the design process. How it can be applied? A design engineer faced with a task of developing new part design must either start from scratch or pull an existing drawing from the files and make the necessary changes to conform to requirements of new parts. Just now if I ask, suppose I will ask Yogesh Survase to draw the model of spur gearbox. So he will start from the scratch. He will first of all draw the profile of spur gear, then he will extrude the spur gear, then he will draw shaft, then key, then bearings, then he will draw um, casing of that spur gearbox. So all required components he will draw from the scratch. But if I ask somebody other, suppose I will ask Abhishek Pawar to draw, he will do some smart work, like he will take the ready-made spur gear which is already saved in one folder. He will take ready-made shaft which are already saved in folders, and he will just do the work of assembling these parts. So he will not draw all the components from the scratch. So what is expected? A smart work is you take the component, modify the component in the software, and you finalize that assembly design. So every time you do not need to draw these components. So I would like to specially mention here the softwares like CATIA, then SolidWorks or Solid Edge. These softwares consist of geometry library of different geometries. There are different size of bearings numbers. All bearing numbers and their specification and their models are already available in the software. You can directly call these models and you can generate the models in a second. So you don't need to draw a bearing. Suppose you want deep groove ball bearing of suppose 6205 size, you will get that bearing. So you want nut and bolts of this specification, you will get this nut and bolt directly in that software. Then you want suppose a spur gear of module 5, you will get that spur gear. So these types of models are already saved in a software nowadays, so you don't need to start it from the scratch. You do not need to start it from the scratch. Again I am repeating, suppose you want to do the design of wheel rim, so these wheel rim with their specification, these are available in a software. So do not go for the separate modeling, it will consume the time, and that can be simply called as a group technology. Now we will move ahead. Part families. This is also very important concept. A part family can be defined as the group of parts or components having the same or identical attributes. Part may not be exactly same, but they are very close. Parts may not look like same, but their manufacturing process can be same. See, you may have doubt in the mind, sir, this is the shaft and this is the gear. This is the shaft and this is gear. They are not looking same, obviously. It is a common sense. But some manufacturing operations are same in shaft and manufacturing of the gear. So you can take them into a part family. So part family, it is not limited to looking of the component same, or they are not limited to only shape of the component. I am repeating my statement. Shape of the component may be different, but their manufacturing operations are same. That can be taken into a part family. I am repeating my statement again. हे फार महत्त्वाचं आहे, थोडंसं लक्षात घ्या. Component shape may be different, but their manufacturing operations are same. That can be taken into a part family. For example, nut and bolt. Shape is different, but threading operation is same in nut and bolt. Shape of the nut is different, shape of the bolt is different, obviously, but the threading operation is there, so you can consider it in part family. Are you getting? So understand this. So it is not only limited to shape. That is what part family. Now according to the part family, you should organize the machines. Now you can see these are complicated structures of manufacturing process. So you want to manufacture one component, it will enter, that raw material will enter in this lathe machine, then it will go to this lathe machine, then it will go to this drilling machine, then it will go to this grinder, and then it will go for assembly. Another raw material will go to this lathe machine, it will go to this drilling machine, then it will go again to this drilling machine, then it will go to the grinder, and then it will go to the assembly. Similarly, this lathe machine, then this drilling machine, this grinder, then this lathe machine. So how much complications are made for traveling of the component? यहाँ पर आपने बहुत सारे कॉम्प्लिकेशंस किए हैं जब कंपोनेंट जो है एक मशीन से दूसरे मशीन तक जाता है, एंड दैट इज फाइनली रिड्यूसिंग द प्रोडक्शन रेट. Unnecessarily you are traveling the component from one machine to the another machine to third, and which are situated at very long distance. It should not happen. So machine arrangement should be specific so that smooth flow of raw material will happen. Then you can see here this layout: lathe machine, drilling machine, grinding machine, assembly, storage point. Milling machine, drilling machine, assembly, storage point. Lathe machine, milling machine, drilling machine, grinding machine, assembly, storage point. So you can see how the flow of the workpiece is, how smooth it is, and you can reduce the production time in this smooth flow. One product, it will be manufactured through this layout, another product will be manufactured through this layout, then this production line. So 4 different products will be manufactured through different lines, and there is no complications in the traveling of the product. So please understand this smooth flow of workpiece. So in manufacturing process, smooth flow of workpiece must happen. So I request all of you to observe the layouts of manufacturing cells. You observe the layout of different manufacturing cells, and you can go ahead to define one manufacturing cell. If you are interested to set up any manufacturing cell, first of all study it very precisely, what type of product you want to manufacture, and for this type of product manufacturing machine cell or different resources, how it can be organized so that there will be a smooth flow of raw material through your machine cell. It will not lose the time of manufacturing. So this must be taken into consideration. Now the advantage of the group technology that we will see, I will just explain in the short. Design reduction in number of drawings, as I told you before some time. Then the reduction in time to identify the drawings. Then easy modification of the design, as I told you by taking an example of spur gear. Second advantage of production planning, reduction in setup time and production time. Then improved machine loading. Then reduction in reduction in work in process inventory. Then simplified production scheduling. Then easy identification of bottlenecks. Then it reduces manufacturing lead time. Then leads to automated process planning and scheduling problem, and then reduces complexity and size of parts. So these are the advantages that you can understand easily, because language is also simple. Then another advantage regarding layout, it reduces floor space required for production. It reduces less material movements. Less material movements means material handling that can be reduced material handling requirements can be reduced because material movement will not be there. Then less material handling efforts, then more flexibility in manufacturing process. Regarding quality control, less number of defects and rejection will happen in group technology. More precise parts will be manufactured, better output quality, and it leads to automated quality control system. Then accurate and quick cost estimates, less number of parts and raw material, and it provides standardized rules for purchasing. So this was about the group technology, and it is very important as far as examination is concerned, and also it is very important as far as your practical knowledge is concerned. So I am most thankful to all of students to be here up to the end of the lecture. Thanks for listening. Now you go to the Moodle and watch 4 video lectures and solve corresponding quiz.